Hello, this is Kedolytics and welcome to today's session. In today's brief video, we are going to look at how we can use the SPSS platform to be able to check our assumptions backing our decision whether we use a Poisson regression model or a negative binomial regression model. Now, if you watch our previous video on this particular channel, you can scroll to look at that video where we check the assumption of deciding whether to use a Poisson regression or a negative binomial regression using the Stata platform. In this video, if you watch it right to the very end, you'll be able to know exactly how you can be able to decipher that using the SPSS platform. Without wasting much time, we want to establish the fact that for us to run a Poisson or a negative binomial regression model, we need to have our outcome variable being a count outcome or variable. And what is that? It simply means that the variable occurs in episodes. So, for example, you're looking at pregnant women over a period of their pregnancy, 9 months. You want to see how many times do they develop a particular condition, perhaps diarrhea. So, over the period, the people develop, one person develop it 2 times, another develop it 3 times, and so on. So that particular variable, the number of episodes of diarrhea, becomes a count variable. You may want to watch the previous video on Stata and see more on the explanation of it and other examples. Now, for us to be able to check that assumption, we have to, this is a dummy data set about pregnant women who we are looking at the episodes of diarrhea they have during the period of their pregnancy. So to check the assumption to see whether our dependent variable, in this case, diarrhea outcome, qualifies for Poisson regression, we have to do what we call a non-parametric test over here, and then select legacy dialogues, and then go to one sample PS. Then we'll click on it. And then, so once we click on it, we have this dialog box, and then we check our outcome variable of interest, which is diarrhea episodes. And then we'll come to options. We want descriptive, so we check descriptives, and we'll continue. And then over here, the default is normal, but then we are interested in the Poisson distribution. You can select uniform, normal, that, but we are interested in whether it passes the assumption for a Poisson regression or not. So we click on OK, and within a few seconds, it gives us our outcome in the outcome window. So it gives us a brief. So yeah, right here in the output window, we have the N-power test, the descriptive stats, diarrhea, number of people involved, the mean, the standard deviation, the minimum, and the maximum. So the minimum number of diarrhea cases a person had over the period is 1, and the maximum is 8. So people had it about 8 times during the period of the study. And we have the Poisson parameters, the mean, the absolute, positive, negative. They are all here. And we are interested in this p-value, which is which is greater than 0.05. So this is 0.163. And so we fail to reject the null hypothesis that this qualifies to be a Poisson distribution. So this is actually a Poisson distribution. And so we can go on to run a Poisson regression analysis. So this is one way to be able to check if your count outcome qualifies for you to run a Poisson or a negative binomial regression model. Another thing you want to do is to be able to decipher whether your model, which you are going to develop, suffers from over-dispersion, under-dispersion, or equi-dispersion. And where there is over-dispersion, there is the need for you to run a negative binomial regression instead of the Poisson regression model. And so to be able to do that, we'll come to Analyze, and then we'll go to Generalize Linear Models, and then we'll come to Generalize Linear Model and click on it. And then we have the model type. The default is usually linear, so you change it to a count outcome and go to the Poisson log linear. And then the response variable, our interest is what? Diarrhea. Earlier on, I ran it, that is why it was there. So you just send your outcome or dependent variable there. And now we want the predictor variables. And so initially they will be this way. And so We want the age. Age becomes a covariate because it's a continuous or a quantitative variable. And then we select all these five variables into the factor variable because they are categorical in nature. And then we go to our model. So we select all of this. So initially this here will be empty. So we'll come here and select all of them and then move them to the model. And then we leave it as the main effect. Now, what estimates are we in? We leave it as the default setting. And then the statistics, we'll check this one, include exponential parameter estimates. So this will help us to have the exponential beta value, which equates to the odds ratio, to help us do our interpretation in relation to the categorical outcomes. And then our confidence interval is 95. We leave all other parameters the way they are. And then we click on what? OK. So immediately we click on OK, we have our output window. We are going to go there to see what we have. So generalized linear model, the model information. It's about the dependent variable diarrhea. The probability distribution we have done is a Poisson regression. And the link function is a log link function. We included all the variables and excluded none. Now, these are categorical variables we have and the various categories. Then we have the continuous variable information. So the only covariate we had was age. And this is the minimum, the maximum, the median, and the standard deviation. Now, this goodness of it presents us with an information which will help us to be able to make, which will help us to be able to decipher or make a conclusion as to whether we'll go ahead with a Poisson regression or fall for the negative binomial regression model. Now, when you look at this value of interest, the value divided by the degree of freedom, when it is close, when it is 1, then there is equi-dispersion. But when it is less than 1, then we know we have under-dispersion. And obviously, when it is greater than 1, then we have over-dispersion. This will guide our choice as to whether we'll settle for this Poisson regression model or we'll settle for the negative binomial regression model. So basically, these are the two main things you want to run using the SPSS platform to be able to help you to decide whether you go ahead to run a Poisson regression or a negative binomial regression model. If you find content such as this useful, we encourage you to like, subscribe, and share our videos with all. Until we meet again on our next one, this is Schedulytics, and it's a bye.